Have you ever really stopped to think about the hidden energy that's packed inside, well, pretty much everything? In this explainer, we're going to dive into how scientists measure the power in all sorts of things, from your lunch to a lump of coal, by, you guessed it, setting it on fire. It's a funny question, right? It connects the donut in your hand to the entire power grid. But that number you see on a nutrition label or the energy rating on a fuel source, that's not just a guess. No, it comes from a super precise measurement. So how exactly do you measure something as invisible as energy? Well, the answer, in one word, is fire. The total energy that's locked up inside a substance, it reveals itself when you burn it completely. And the science of capturing all that heat and measuring it with incredible accuracy, that's called calorimetry. So what's the right tool for a job like this? Let's meet the hero of our story, the bomb calorimeter. And yes, it sounds intense because it kind of is. It's this amazing instrument designed to do one thing and one thing only: capture every single bit of heat from a tiny, controlled fire.
The best way to think about it is like the ultimate thermos. I mean, it's a perfectly isolated system designed so that absolutely no energy can escape. When a sample burns inside, all of that heat has nowhere to go. It gets completely trapped and absorbed by the water around it, which is exactly what we need to measure.
So let's break this thing down. At its heart, you've got the bomb, and that really is what it's called. It's a thick-walled steel container that's built to handle some serious pressure. This bomb then sits inside the bucket, which is filled with a very, very precise amount of water. And then wrapping around the whole shebang is the jacket. This is the final shield, making sure the only temperature change we measure comes from our sample and not from, the air in the room. Okay, so we've got the tool. But what's the science that makes it all work? Well, it's an idea that's actually pretty elegant and is just fundamental to how we understand energy itself. The whole field is known as calorimetry, and at its core, it's really just the science of measuring heat transfer. It doesn't matter if it's a chemical reaction, a physical change, or in our case, a tiny explosion, calorimetry is how we put a number on the energy involved. And this right here, this is the secret sauce, the first law of thermodynamics. You see, the fire doesn't create energy out of thin air. It just releases the energy that was already locked inside the sample's chemical bonds. So the calorimeter isn't really measuring fire, it's just capturing that energy as it changes form from chemical to heat. And here's where it all clicks together. The chemical energy from the sample bursts out as heat, and that heat gets completely soaked up by the water. And since we know exactly how much energy it takes to raise water's temperature by just 1 degree, a simple thermometer reading tells us everything we need to know. That change in temperature is directly tied to the sample's hidden energy. Simple as that. All right, now that we've got the theory down, let's actually walk through how a real experiment happens inside the calorimeter. It's a super carefully controlled 4-step process. Okay, here we go. Step 1. You start with a tiny, precisely weighed sample. You seal it inside the bomb, then pump it full of pure oxygen. That's to make sure every last bit of it burns. Next, the whole bomb gets submerged in the water, and you wait a bit for everything to settle at the same starting temperature. And then, showtime. An electric current ignites the sample, and all we have to do is watch the thermometer. That final peak temperature is our magic number.
Measuring energy with this much precision is pretty cool. But why does this one number, the calorific value, matter so much? Well, as it turns out, its applications are everywhere. We're talking from our kitchens to our biggest industries.
Just take a look at this table. It shows the huge difference in energy density between fuels. Hydrogen is an absolute powerhouse. It packs an incredible 150 kilojoules of energy per gram. Compare that to wood, which only has about 17. This measurement has a name, the gross calorific value, or GCV, and knowing the GCV is absolutely critical for designing everything from jet engines to power plants. It tells you exactly how much punch you get for every single gram of fuel. Now, the bomb calorimeter is the master when it comes to solids and liquids. But what about gases, like natural gas? For that, scientists use different tools, like a Boy's or Junker's calorimeter. Instead of one single bomb blast, these devices measure the heat from a continuous, steady flame. But you know what? The core principle of capturing heat by warming up water, that stays exactly the same. So let's bring it all back home. That calorie count on your snack food? That number probably came from a bomb calorimeter. The quality rating of fuels like coal or kerosene determined the exact same way. This one tool is really a cornerstone for everything, from fundamental scientific research to industrial quality control. It's a big deal. Being able to precisely measure energy is really the first step toward managing it better. The bomb calorimeter gives us the cold, hard data we need to make smart choices about nutrition, about energy efficiency, about which fuel sources to use. It turns this abstract idea of energy into a concrete, usable number. So the real challenge then isn't just measuring it, it's using that knowledge to build a smarter, more efficient world.